All right. Good morning, everyone. So, welcome to chapter 10 for the scripting class. In this chapter, we're going to take a closer look at our new microcontroller using the ESP32. We're going to explore what makes it actually so special and dive into some of its most important features for our projects. We're going to be looking at Wi Fi and Bluetooth capabilities. So far, we've learned a lot of core concepts. Now it's time to focus on the hardware itself. This chapter is going to compare the ESP32 to the classic Arduino Uno, and we're going to highlight its advantages. Our main goal is to understand and utilize all the built in wireless capabilities. Now, this is going to be essential for us to create some of our new automation systems and look into what we like to call Internet of Things, otherwise known as IoT devices. Now, a good way to look at these two boards is with a car analogy. The Arduino Uno is like a trusty, reliable first car. It's fantastic for learning the basics of driving, how the engine works, how to steer, and the rules of the road. But the ESP32, on the other hand, is more like a modern vehicle packed with like the latest technology. It has built-in navigation, which is like its Wi-Fi. It has a hands-free calling, which is Bluetooth. Both cars are great, but they are designed for different purposes. Now, the ESP itself is more than a simple microcontroller. It's what we like to call System on a Chip, or SoC for short. This means it integrates more components like a powerful processor, memory, wireless radios, all into a single piece of silicon. Now, its most important features, and the reason why we use it for IoT, is the built in Wi Fi and Bluetooth. So let's break down the differences. First, the processor. The ESP32 is fast. It is a dual core processor that normally runs up to 240 megahertz. Having two cores is an advantage, and it means that the ESP32 can literally perform two tasks at the same time. For example, it can manage a web server on one core while controlling motors and sensors on the other. The Arduino Uno, on the other hand, is much simpler. It is a single core processor, normally only running at 16 megahertz. It's significantly slower and can only do one thing at a time. The major differences when it comes to memory, well, the ESP32 just comes with a lot more of it. It typically is around 520 kilobytes of SRAM, and it's good for storing programs while you're running, and about 4 megabytes more for the flash memory for the program itself. So this is our long time storage, okay? The Arduino Uno, on the other hand, only has 2 kilobytes of SRAM and about 32 kilobytes of flash. So if you can look at this, much less that we can save onto the Arduino Uno. For our complex projects, especially those involving networking, you can run out of memory very quickly on an Arduino Uno, so we use the ESP32. Now, one of the biggest advantages, and for our purposes, is going to be connectivity. The ESP32 has Wi-Fi and Bluetooth built right into the chip. You don't need any extra components to get it online. The Arduino Uno, however, requires you to buy and connect external shields or modules to add any wireless capabilities. This adds cost, makes the project physically larger, and increases the complexity of your code and even wiring. Now, there are some key differences when it comes to the operating voltage. You always must remember this. The ESP32 runs on 3.3 volts. The Arduino Uno runs on 5 volts. The difference is extremely important. If you connect a sensor or a device that outputs a 5 volt directly to an ESP32 pin, you can permanently damage the microcontroller. You must be careful and use components that are 3.3 volt compatible, or use a level shifter to convert the voltages automatically. Now, the ESP32 You can run it between 4.5 volt and 15, but know that you have to use the 5-volt pin for this, and it's using a voltage regulator to regulate the power down. This is why we can run it on a USB, because the voltage regulator will downgrade the voltage from 5 volts to 3.3. Now, in terms of programming, the ESP32 is very flexible. You can program it with the same way that we do our Arduino with Arduino IDE in the C++ language. You might be familiar with that, but you can also use more advanced frameworks. Our focus on this course is going to be using MicroPython. Now, it's very similar to using Python language, specifically designed, but remember that MicroPython is specifically designed for microcontrollers. The Arduino Uno is primarily programmed using its own simplified version of the C++ and the Arduino IDE. So which one should you use? Well, which board is going to be right for your project? It all depends on your goals. You should choose the ESP32 if your project requires any kind of wireless communication. If you need any more processing power or memory, or if you're building a battery-powered device where lower power consumption is important. You might choose the Arduino Uno if you're a complete beginner, looking for the simplest possible platform. Now, if your project has no need for wireless, or you're using older sensors that are designed for 5 volts, the Arduino Uno might be your way to go. 9 times out of 10, I would say that's not the truth. I prefer the ESP32 just for the extra capabilities, and honestly, the ESP32 is a cheaper solution. Oh, just a second. I lost the ability to control my screen. Let me fix that real quick and I'll continue on with the video. All right, moving on. So slide 10, the basic MicroPython script structure. According to the recording here, it doesn't show it though. This is always great. Alright, let's bring in the screen again. Screen capture. We're gonna do this one. Hit OK. All right. Now let's try this again. Let's go with slide 10. All right, so let's talk about that MicroPython script structure. Now, we're going to use that to write our code for ESP32 using MicroPython. A MicroPython script runs sequentially from the top line to the bottom line, okay? Now, this is different from the Arduino C++ code that we learned about. C++ code, which is organized in the setup and the loop structure, okay? Now, in MicroPython, the first thing that we might want to do is import our modules. Now, MicroPython has modules. Modules are a collection of pre-written code that gives us access to certain features. We also like to call these modules libraries. You must import them at the top of your script, and the most common ones that we like to import is going to be machine, because machine is used for controlling hardware like the GPIO pins themselves, time for creating delays, and network for used for Wi-Fi and networking. Now, after we import our modules, we're going to then configure the hardware. This is similar to what we do in the Arduino setup function. This is where we're going to create objects that represent physical components. For example, to control a GPIO pin in MicroPython, you're going to use the machine.pin class. The line LED equals machine.pin, and then in parentheses 2, machine.pin.out creates an LED that controls on pin 2 and is an output device. Pretty much like we do in the C++, it just looks a little bit different. Now to make the code run continuously, just like on Arduino loop function, we'll do something that we like to call an infinite loop. In Python, this is done by taking the while true loop. Any code that's intended to run inside the while loop will be executed over and over and over until the device is powered off or even reset. Now for the main event. We're going to connect to the Wi-Fi network. This is the core strength of the ESP32, and it's the first step in creating any IoT device. Getting your ESP32 online allows it to communicate with other devices, send data over to web services, and can be controlled anywhere in the world. The first step we need to do is we need to specify our Wi-Fi credentials. This is the SSID, service set identifier, and the password. Next, we need to create an object to represent the Wi-Fi hardware. When you want to connect to an existing Wi-Fi network, like your home router, we'll use what's called the station interface, or STA_IF. Before you can connect to Wi-Fi, we need to turn it on. So you do this by creating the active_true function. So you do, if your Wi-Fi is called WLAN, it would be WLAN.active_true. Once it's active, you can begin the process of connecting. So then we would use our object, WLAN.connect, and we'll pass it the SSID and the password we defined earlier. Once the ESP is successfully connected, the router will assign it a unique IP address. This address is how other devices on the local network is going to find it and communicate with it. You can get all of the details, including the IP address, by using the ifconfig method. Okay. Right there, ifconfig. All right, so our lab is going to be 10.1. What you're going to do is you're going to take a MicroPython script, and your goal is to successfully connect to ESP32 to your Wi-Fi network, and then print the IP address to the console. It's a very simple script, but this is the script that the rest of the class is going to be built on top of. We're going to make sure that the device is online and ready to be used as an IoT device, because starting in next class, we will take it to the next level and connect it to an online service. All right, to summarize, in this chapter, we've learned the key differences between the ESP32, the Arduino Uno, and we understand why the ESP32 is very superior when it comes to performance, built-in connectivity, and the ideal choice for an IoT application. Most importantly, we've walked through the fundamental steps to get our ESP32 online. And then we are going to then take this foundation and connect it to other projects that we build from here. All right, sorry about the hiccup around slide 12. Hopefully everything's all in great from now on. I'll see you for the next chapter.